In this video, we're going to discuss absolute value inequalities. Let's begin with the fact that we know that in the equation absolute value of x equals 4, that the value for x could either be negative 4 or 4, because the absolute value of either number is a positive 4. So, to write the solutions, now that we move to inequalities, if you can see here, and we're going to start with this example, the absolute value of x is less than or equal to 4. It's important to remember that the absolute value is talking about the distance from 0. So with the inequality, we can see that numbers like negative 3, right here, would give us a number less than 4 once we take the absolute value, because the absolute value of negative 3 is equal to positive 3, and 3 is less than or equal to 4. So what we're saying is that all numbers between negative 4 and 4 would make this statement true. Because even though these negatives may seem a little bit confusing at first, because you're thinking, well, wait a minute, negative 1 is actually greater than negative 4. But remember, we're talking about what goes in the absolute value place. So we're talking about the numbers we plug in for the x, and then once we take the absolute value, that answer has to be less than or equal to 4. Okay. So we can see here, this looks like a graph that we've done before. So to write the solutions in both inequality form and interval form, we know this is a continuous inequality. We can see that from the graph, because we know all the answers have to be between 4 and negative 4. So as a continuous inequality, we write this as a single inequality and a single interval. So inequality notation, we have our x in the middle because it is greater than or equal to negative 4 and also less than or equal to 4, which is correct. Greater than negative 4 takes the graph this direction, and being less than 4 takes it in this direction, and they meet. So we have a single interval notation, negative 4, comma 4, and note I'm using the square brackets because this is a less than or equal to symbol. Let's look at another equation. The absolute value of y is greater than 4. So for this to be true, the y value must be greater than 4. For example, if we set y equal to 5 and plug that in for y, we get the absolute value of 5 is greater than 4, which is true because the absolute value of 5 is positive 5, and that is greater than 4. The negative side is a bit tricky at first to see. So remember, this is about the distance from 0. So if you look at my grid down here at the bottom, if I go and find negative 5, I'm going to take negative 5 and plug it in for y. So I'm getting the absolute value of negative 5, which is 5. That 5 is greater than 4. Because again, what is greater than 4 is not what's inside, but what you get after you've applied the absolute value. And that is why on this graph I have numbers greater than 4 and what looks like numbers less than negative 4. But it's because you take the absolute value of those negatives and they become a larger positive number. Let's solve the absolute value of 3x plus 5 is less than 8. Now we saw that if the absolute value must be less than the given value, we will have a continuous inequality. So to solve this, we set up our inequality like this. Negative 8 is less than 3x plus 5 is less than positive 8. And again, because we can see now that the value in the middle, what we're trying to do is once we take the absolute value of that, it's going to become a number that's either greater than negative 8 or less. Let's go ahead and solve this, and then we'll write our answer in interval notation and graph it. So let's begin with the solving. Continuous inequalities allow us to simply combine the two. So to isolate the 3x, I'm going to subtract 5, but I'm going to do it to both ends after both sides of the inequality sign. Now I'm going to finish by dividing both sides by 3. And excuse me, now we have negative 13 thirds less than x less than 1. So that is our inequality notation. Our graph, we could go down to negative 13 thirds. And again, when graphing an improper fraction, just change it to its mixed number form. 3 goes into negative 13 4 times, so I know I'm going to at least go negative 4. And then another third. So there's my first point, and x is greater, so it's going to go to the right. This was 0. I'll go to 1. Again, open circle because it's a less than, not a less than or equal to. And it's going to be a single graph. So now what we're going to do is take a look at another example. Let's solve the absolute value of x plus 4 minus 6 is greater than 8. As with solving absolute value equations, we must first isolate the absolute value sign. So to do that, I simply add 6 to both sides. And now I have to solve absolute value of x plus 4 is greater than 14. Now we saw that the absolute value must be greater than the given value. We'll have a situation of what we call a this or that inequality. In other words, we have two separate inequalities. So to solve this style, we set up our inequalities like this. We have our x plus 4 is less than negative 14. Our x plus 4 is greater than 14. Once we solve this, we will put them in interval notation and graph it. So we'll go ahead and go through, do our basic algebra. We end up with x is less than negative 18, and x is going to be greater than 10. Now to graph this, we have our low number of negative 18. We'll pop a 0 in here. Upper bound is 10. But it's less than negative 18, so that means I'm going to be going out to the left. And from 10, I'm going to go out to the right. Now, because of the fact that I have a split graph, it means that for my interval notation, I'm going to have two separate intervals connected with the union symbol. We'll start, as it's going to the left, with negative infinity. Curved parenthesis for infinities. This brings me to negative 18 as the largest of those. Curved parenthesis because we didn't have an equal sign in there. It's added to, or it's union. Remember, this means or, so we have this interval or a new interval starting at 10 and going to positive infinity. So since our graph splits and goes out, our interval notation is split. We have two of them.